going to run through our exit slip 4-1 answers and discuss a little bit of the new concepts. Our I can statement was to be using calculators, to be renaming exponential expressions and standard notation, and just dealing with exponents in general here. Okay, so at the beginning here, we're just supposed to write each expression using an exponent in here. Doesn't need me to get the full answer. It just wants to do it with in standard notation. It just wants the answer as an exponent here. So remember, we learned with exponents, when the 3 is repetitive here, that's the base. So we have 3, and then count how many 3's you have. 1, 2, 3, 4, 5. So this would be 3 to the 5th power. And that just means we multiply those 5 3's all together. So 3 to the 5th power there. B, we've got 81. What equals that with an exponent? And again, kind of got to know your facts here. We can talk a little bit about the square root we talked about. What makes what times what equals 81. And in this case, it's 9. Okay, so 9 to the 2nd power. We say 9 squared. Simply means 9 times 9. All right, so in this case, that would equal 81, we know. Again, the mistake people make, they just think, oh, 9 times 2, that's 18. But remember, it's not 9 times 2. If it was 9 times 2, we would have written 9 times 2. It's 9 to the 2nd power, which means we have 2 9's multiplied together. So same thing here, 2.5 is the base. There's 3 of them, so 2 5/10 to the 3rd power. This means 2.5 times 2.5 times 2.5. Now, when we get to the 1,000, it gets a little more complex here. This is actually a cube root. If you think 10 times 10 times 10, that equals 1,000. So 10 to the 3rd power there. 10 times 10 is 100, times another 10 is 1,000, because we know every time we add a 0, it makes it 10 times bigger. So again, I see 3 zeros there. That's 10 to the 3rd power. Next one, we see quite a few mistakes on these. This is 1/4 times 1/4, or 1/4 to the 2nd power. But we need to use parentheses here because we want the whole thing twice. 1/4 2 times. If you just do this and do 1/4 squared, that just squares the 1 and doesn't square the 4. So this just ends up 1/4 again instead of 1/16, which is what this would equal if we solve that. So this is definitely not what we want to do on here. Get those parentheses saying we want it all together twice. So this would be the similar. 3 times 3 is 9, so 1/3 to the 2nd power would be 1/9, because 1/3 times 1/3 is 1/9. So little technical thing there with parentheses that a lot of us didn't know that we need to start to think about a little bit. Down below, we're going to be using that calculator a little bit, and I'll show that here on the screen in a second to try to come up and show what these might equal. So 2 to the 8th power, again, people think 2's aren't very big, but when you're taking 2 times 2 times 2 times 2 times 2, you have 8 of those 2's. You get up there pretty quick. A lot of people will guess low, so I'll just say, oh, maybe 100. All right, so if I switch over here, we're going to get our calculator value and see what it really is. It turns into a lot of multiplying work when you do that, so we have calculators. We'll show the TI-15 here real quick, and I'll show an example here. So if we want to take a look, the one we had was 2 to the 8th power, so I could plug in 2, and then this button right here, the little asterisk, the little thing that pointing up there, kind of hard to see on the calculator, but 2 raised to the 8th power, and then we can hit equals, and you see the answer comes up 256 there. I think you can see that. So 2 raised, that caret there, this button right here on the TI-15s, and it gets pretty big pretty quick. The answer gets up to 256. So if we flip back here, the calculator value was 256, and I was too low there. A lot of times we will guess low. When we do exponents, things can grow pretty quick. 9 to the 3rd power, if I'm thinking an estimate of 9 times 9 times 9, so this one I could probably get a little better estimate. 9 times 9 is 81. Let's just say 80, and 80 times 9 again, maybe about 270. Do some mental math in my head there. When I do 9 to the 3rd power, well, excuse me here, estimate there, multiplied a little wrong. 9 times 9 is 81. 80 times 9, no, 8 times 9 should be 72, so maybe about 700-ish, somewhere around there. So when I do 9 to the 3rd power, I believe 9 times 9 times 9 will get 729. So again, I'm a little low, but I can do some mental math and only have to multiply things together 3 times. So I'm fairly close there. Now 4 to the 10th power, that gets a little tough to estimate. 4 times 4 times 4 times 4 times 4 times 4, etc. You have 10 of them. So I'm going to guess a little bigger. You know, a lot of kids will guess really low. I'm just going to say, how about 100,000? Again, some may think that's going to be too big. But when I do 4 to the 10th power, we actually will come up, and again, I'm not going to go show the calculator on every one of these, 1,048,576. So we're definitely way too low on that one. People see the 4 and it's pretty small and think it won't be that big, but if you're taking 4 times 4 times 4 times 4, you get 10 of them, it gets pretty big pretty quick. 24 to the 3rd power, I'm just going to do a little estimate, like 20 to the 3rd power, so 20 times 20, 400, and 400 times 20 more, well, maybe around 8,000. And if I do the work, 24 times 24 times 24 in my calculator, I will get 13,824. And again, my estimate was a little too low on most of them, is what we normally see. But we're going to be using these calculators a little bit, these TI-15s, and we'll do some exponents because the numbers get so big. We're going to use that technology to help us solve these a little bit better. So again, really understanding what the base is and the exponent here and how to write these in exponential form. And then down here we kind of got them do their standard notation to see what they actually would get to when I do the multiplying there.